Hey Becca, what are we learning today?
Today, we will be simplifying radical expressions. Today we're learning about simplifying radical expressions, but I want to go through some simple radical expressions before we learn to simplify the complicated ones. If we have a perfect square underneath a square root, it's easy to find the value because we just have to figure out what number squared will give you the number under the square root. So as you know, the square root of 4 is 2, just like the square root of 16 is 4 because 4 times 4 equals 16. And likewise, the square root of 25 is 5 because 5 times 5 equals 25. But what if we have a square root and we have 25 times 3? Because it's multiplication underneath the square root, we can actually break this up into two square roots multiplied together. The square root of 25 times the square root of 3. We just saw that the square root of 25 is 5, and the square root of 3 is not reducible because 3 is not a perfect square, so we can leave that inside of the square root. So this is our answer, and it's not reducible anymore, but you just found the square root of 25 times 3. 25 times 3 is in fact 75, so that's the square root of 75 that we just calculated here. Now, you can use this method to calculate any square root by just isolating a perfect square within this number. We're going to use that same method to find the square root of 32 and the square root of 112. If we start with the square root of 32, 32 itself is not a perfect square. But if we can find a factor of 32 that is a perfect square, then we can reduce this radical. 32 can break up into factors 2 times 16. Now, 2 is not a perfect square, but 16 is a perfect square. So because it's multiplication underneath the square root, we can break this up into two square roots multiplied together. The square root of 16 is 4, and the square root of 2 we will leave underneath the radical because it's not reducible. So the square root of 32 reduces into 4 times the square root of 2. Let's do the same thing with 112. Now, we don't necessarily know the factors of 112. I don't know if 4 or 8 or 16 goes into 112, but I do know that it's divisible by 2 at least. So let's break it up into 2, and 112 divided by 2 is 56. Neither of these are perfect squares, so that doesn't really help, but we can break up the 56 again by 2, so we leave the 2 from before, and then 56 breaks down into 2 times 28. Now, 2 times 2 is now underneath the square root, so this can be rewritten as the square root of 4 times 28. And look, we have a perfect square. We can break it up into two square roots. The square root of 4 is 2, and we leave the 28 inside. Now, we're not finished yet because 28 can be broken down again by 2. We're going to leave the 2, carry it down. 28 can be broken up into 2 times 14, and yet again 14 can be broken down as well. 2 root 2 times 14 breaks down into 2 times 7. We've got 2 2's. 2 square root of 4 times 7. Carry it down. we can break this up into 2 square roots. See how we went from 4 times 7 underneath into 2 separate radicals. And now we know the square root of 4 is 2 again. So now we have 2 2's multiplied together on the outside, square root of 7 on the inside. Since 7 is a prime number, it cannot be broken down into any more factors, so this is irreducible. We'll leave it underneath the radical sign, and you just combine the terms on the outside. So our final answer is 4 root 7. And that is the simplified version of the square root of 112. I have one more example to show you that is rather trivial, but I think it's important to see. If we try to reduce the square root of 33, we can use the trick that we used before, and we try to break 33 into factors. 33 can break down into the square root of 3 times 11. And those are the only factors that are in 33. It turns out that 3 and 11 are both prime numbers. And prime numbers are not perfect squares. Since they're not perfect squares, we cannot isolate any term, and we cannot take the square root of either. So the square root of 33 is actually irreducible.
Thanks for watching my video today on simplifying radical expressions. If you found it helpful, make sure you give it 2 thumbs up and share with a friend who you also think might find it helpful. If you have any questions, leave them in the comments and make sure you subscribe to stay up to date. New videos every Monday and Thursday. Have a great day!